Hey everyone, in this video, I want to show you the improved version of my scan effect. This time, I have added a lot more effects and I have also fixed a lot of bugs that the old one had. Like the old one sometimes don't highlight some actors etc. And this time, I have also added this Niagara particle systems and these cool highlights. And also, this time there are a lot of controls. So if I go here and activate the scan effect, I can see them through the wall. And here I can see these effects like this. I also have some Niagara particle vortex flying around when I activate the. So here if I look at the scan effect, you can see that I have a lot of controls here. So here you can see that I have a desaturation amount. If I set that to 0 and the background color to white, then if I press play, I will get this effect. If I set the desaturation to 1, I can set this background color to whatever I want. So if I set this to like a red color, like this, or a pink color, I get a view like this. I can set this to like a blue color or a violet color, and I can get a view like this. So you can change the background color to whatever you want and you can get a cool looking effect. There is also this curve. So if I just change the hue here to an yellow color like this, and now if I press E, I get this look. You can see that just by changing the curves, the particle color also changed. So you can adjust the entire look of the effects by just changing one curve asset like that. And it will also fade out in a nice and smooth way like this. There is also the control for enemy color, front color, neutral color, etc. And like last time, you can also use a pattern that you like. So if I go to the starter content and use this fire texture, then I will get an effect like this. And if I select this purling noise, I can get an effect like this. So if you support me on my Patreon, you get all these textures. So if I select this one, I will get a look like this. This is kind of a digital look. And if I select this pattern, then I can get a look like this. And this pattern will give a look like this, like a plasma look. I can also change the curve color to something different, like a pink color. And now I can use this texture. So it will look like this. And I can also use these pattern textures, which will give a look like this. You can also use whatever texture you like. You can also change the texture tiling here. So if I set this to 20, I get a bigger line. If I set this to 1, then I get a look like this. I will set this to 7 and I will select this pattern and I will change the BG color to a greenish color and this one to like a green color also. So now I get a look like this. I think it's better to set this to 1. Let's see. You get a cool look like this. And here if I select this and if I go here, you can see this type. If I set this to enemy, it will be red in color. So if I press play, so now it is red. So you can easily control what highlight color you want on your character or on an item. So here if I set this to front, then it will be green in color like that. And if I go here, I can also change the scan duration. If I set this to like 10 or something like that, the scan will stay on for like 10 seconds like that. So this is what we are going to be making today. This project file also have this bonus effect that I am giving to my patrons. So it looks like this. And here if I press the Q key, you can see that there is this outline around the world and these objects are highlighted with different patterns. So if I go here, I can also see them through the wall like this. And if I just select some object, And here, if I set this to custom depth of 1 and press play, and then I get this effect. So this one is just a single post-process material that looks like this. There is no Niagara effects and no sphere trace or anything like that. Just one post-process material that is doing all of this. So it's really simple to set up and really simple to add items to it also. It also works like the other one. So if I set this to like friendly here, now it is green. And it also comes with a lot of parameters that you can change. So there is a BG color. So if I change this to pink, I get a look like this. And I can change the outline color like that. And here I have different types of colors for different types of characters. And also I can add new patterns to them. So if I add this to neutral, and if I set this back to neutral, then I get this look. I can also set it to this and I get a look like this. So you can change this look by changing these textures. Then there is also this pattern on the world. So if I increase the brightness of this pattern, you will be able to see it. So there is this pattern on the world and it looks really cool. You can also experiment with different patterns if you want, if you like this. Maybe that's a bit too much. You get the idea. I will set this color to like 0.5. So now I get a look like this. So if you support me on my Patreon for $5, you can download all these textures and both the project files and all the project files I have created in the last 6 years of my channel from there just for $5. And if you are already my patron, thank you very much for supporting me. It means a lot to me. Thank you. First, we are going to create the post-process material. So for that, right click, then click material, and I will call this m_scan, then open it up. Now we can set the material domain to post-process, and we can set the blend in the blendable location to before tone mapping. So it will ignore anti-aliasing so that our post-process material won't flicker. Now first thing we are going to create is the texture on the ground. So for that, right click, then type in world aligned texture. This node will allow us to map our noise texture onto the world. Now we can bring in a noise texture. For that, we can go to the map. Now we can go to the starter content and textures. And here there are a lot of cool options. I'm going to use the Perlin noise for now. So we can bring that in. And here it needs to be a texture object. So we can just convert this to a texture object and connect it here. Now we can get a scalar parameter by pressing only S and clicking. So, and we can call this texture size. Now connect it to texture size and set the value to like 500. And now for the world space normal, we can get a scene texture, and from here we can get the world normal. So connect that here. And here we can see XY texture C. We need the XYZ, so we get all three axes. So get that. And now we only need one channel from this. So we can just get the R channel by using a component mask like this. And now connect this to MSC color. And now you can see that it is mapped to the world like this. Now we can get a sphere mask. So right click and type in sphere mask. So this sphere mask will just create a sphere around the locations we give here. So if I give world position here, and for B, if I give camera position in world space, and if I connect this to the MSC color, so you can see that there is a sphere near our camera. So if I increase the radius, the sphere is bigger, and I can reduce the hardness to 0. So now it's softer. Now here I want like a ring shape. So for that, I can just do a cosine here, and I will just saturate this value. So this will give an output of -1 to 1. I just need 0 to 1. So I will just saturate it, which will clamp the output. So if I connect this to the MSC color now, we get a ring shape like this. Now here we can just 1 minus this to invert the mask. So now it looks like this. Now we can just multiply this texture with this, so it will only appear at the white color portion. So now we get a look like this. Now if I click apply and if I just create an instance, now I will add this to the post-process material here. This is just for testing. Later we will add this to the camera in our third person character, and with that we will be able to control that using blueprint. Now go to the post-process material and click add and asset and just add that here. So now if I press play, I have something like this. And if I just open this up, and here for the radius we can create a new parameter called max radius and connect it here, and maybe I will set this to like 5000. And now if I press play, we get a look like this. So now I will just disconnect this and move it here, and we will later work with this. Now we need to give different colors to different objects in the world. So in order to do that, we need to go to edit, then go to project settings, and now we need to enable stencil. So here if you type in stencil, you will get this custom depth stencil pass. So here select enabled with stencil. It is like custom depth, but it will give us 256 different IDs for our post process masking. Now we can go back to the material and here type in stencil and get stencil mark compare. And if I press 1 and click, I will get this constant value. I can give it a value of 1 here. And if I just connect this to the MC color and click apply, here you can see that they are already glowing because they already had that value. So if I select this wall and here if I type in custom and here tick render custom depth pass. Now if I just give a value of 1, it will be white. But if I give a value of 2 here and click apply, it will be black again. So if I give 2 here, it will be given a white color. So we can mask out different objects like this by giving different custom depth values and changing that here. So if I just get a lerp and connect it here, and if I connect this to the MC color, and now if I right click and type in scene texture and get this post process input node. So this is our normal color. So if I connect it to the MC color, you can see that we get our normal color back. But now if I connect this to A and if I connect this to the MC color, and here this B value will be outputted if this alpha value is 1. And 1 also means that it is white in color, like you saw here. So if I just get a vector parameter by pressing and holding V and clicking, and I can name this enemy color and connect this to B. So now we get an error because this is a 4 vector. So we can just mask this and make sure to tick B also. Now connect it here. And for the enemy color, I will give a red color like this and click apply. Now you can see that it is red. And if I just duplicate this, and here for the custom stencil value, I will give a value of 1. So it went back to the normal color. Now we can also have another lerp and we can connect it here. And here we can give a value of 1 and we can duplicate this. And we can give a value of 2 here and duplicate this again. And duplicate this again. And give a value of 3 here. So connect this to the MC color. Now get another vector parameter. And this one will be friend color. And now change this to like a green color. Now get another vector parameter. And we can call this neutral color. And now this color can be yellow or whatever you want. Now if I click apply, so now you can see that one is green because the value is 2 here, and this is red because it is 1. And if I just duplicate this and change the value to like 3, you can see that it's yellow. So now I'm just going to delete these and I will set this to 0, untick that. Now we can just bring in the character mesh. So if I just go to the characters folder and here I will get this mannequin, and here I can tick this and set this to like 1 or 2. Now you can see that it is visible through the wall also. So this is what we want. Now we need to make sure that it looks like a highlight. So in order to do that, here we can just Fresnel, and here for the normal, we can just get the world normal. And if we multiply these two together, now you can see that we are getting a highlight effect like this. But our world is also getting highlighted. So we don't really need that. So we can just connect this to the MFC color. I will just bring it up like this and then get 3 multiplies. And then we can just multiply each of them with the Fresnel. So now we will get a really nice highlight effect like this. And here we can also increase the value to like 5. So it will glow. Or we can increase this value further. So if I set this to like 50 and 50, and 50 here, it will glow a bit better. And we can also go back to the material and set the base reflect to 0. So we get this really nice glow effect. We also want to desaturate the world when this scan effect is on. So for that, we can go to scan material, and here for the post process, we can get a desaturation node and connect this to A for the LUR. So now the world is desaturated. So if I press play, you can see that the effect look like this. So here, if I go here, it is appearing black. I think this is due to the base reflect here. So we can give a value of 0.1 and let's see. So now it's working. Now to make it look better, we can go back to the material and set this value to like 2 for the exponent and click apply. So now we have a nice looking highlight like this. So this is what we want. Now we have both our texture and our highlight working. Now we need to put them together. So in order to do that, go back to the material. And now here we need to get a scalar parameter, and we can call this alpha. And this alpha, I will just multiply it to the maximum radius and connect this to the radius. So we can go from 0 to 1. So just set the slider max to 1. So this alpha goes from 1 to 0. Now here we can get a LURP and connect this to the 0 here and connect this to the MC color. And this post process output, we can bring it down. We can connect this to the B here. And for the alpha, we can use the sphere mask like this. So click apply. And here if I increase the alpha like this, here you can see that at 1 and 0 it is highlighting, but this is not what we want. That is because of the cosine. We don't really want the cosine here. We just need the sphere mask. So just connect that to the sphere mask like this without the cosine. Now click apply. Now we get a look like this. And that's not what we want either. We need to 1 minus this. Now at 0, we don't really have any of the effects. And at 1, it is all highlighted like this. Now we need to also add our texture to the world. So for that, we can get another LUR and connect this to 0 here. And now connect this to B. And for this one, we can just multiply this post-process input 0 by 0.1. So it will be really darker. Disconnect this and get a vector parameter. And now we can call this noise color. Then connect it here. And now we can give it a blue color like this. And now just get a blend overlay So now we can overlay our color with the noise texture to the normal colors of the world. Here for the alpha, we can just connect it directly. Now here you can see a noise pattern moving through the world, but it isn't really that visible. We need to fix that. So I will just take the noise color and make it brighter, maybe like 50. So now we need to make this bigger. So for that, we can go to maximum radius and give value 1. So now the value is 15,000. So now we get a noise pattern that moves like this when we increase alpha. And there are a few more things we can do. We can go to the material, and here before the overlay, we can just get a saturate and now get a subtract. And now get the same alpha. Make sure that it is the same name. So we share the same value. And now multiply this by 0.3. So this alpha value is a bit smaller than our original alpha value, and connect this to the subtract. So as we increase the alpha value, we'll subtract some textures from it, but with this offset 0.3, and this saturate is here so that the values are clamped between 0 and 1. So it will give us an interesting effect. Now one more thing to do is that we need to get another subtract here and connect the alpha again, and this time we will also saturate this. So we don't really want anything that we connect to the alpha to go above 1 because it will cause some issues. So just saturate that. So now here I'm just going to connect this directly to the blend. So let's see what happens. So we get a look like this. Now we can increase the texture size like this, and we can increase a value a lot. So here we need to connect this one to A and this one to lerp of this one. So we get the effect inside the sphere, and we don't really need the 1 minus here. So now click apply. And now if I set this to 0, the effect is gone. But if I increase the effect, you can see that our effect is now showing up inside the sphere mask. Now for this alpha here, this one will only affect everything inside the radius, but we want everything in the world to be affected when the alpha is 1. So in order to do that, we need to change this alpha into this alpha again, connect it here. So when this alpha value is 0, we will get our normal color, but when it is 1, we will get the color from this lerp, which is a combination of this masked color and also this noise texture. So here we also need to make this a bit more faster, so we can multiply this by 3 and then saturate this, and now connect this to the alpha. So now if I click apply, now if I increase the alpha, you can see that everything in the world is highlighted and the world is desaturated. And if you don't want this desaturation, you can just go here and connect this to the lerp without the desaturation. So if I click apply now, we will get this effect. You can also have whatever effect you want. If I get a multiply and connect this here and get a vector parameter and kind of give it a bluish color and connect it here and click apply, now we have a blue colored effect like this. So you can also have this. So now I will just call this background color, and if I set this to white, then it will just look normal. And if I set the background color to something else like this, it will look like this. So if you want, you can also do this. So now we can add some motion to our noise texture. So in order to do that, we can go back to the material. And here in the world position, we can get a world position node, and then we can get this and type in append vector. So we can connect this C here. But before connecting that, we can get a time node. This time value will go up and up. So we have a continuously increasing value here. And we can multiply this with a parameter called speed and connect it here. And we can add the C value with the time value. So it will change with the time. And we will just append this with X, Y. So it will be a 3 vector. Now we can connect this to the world position and click apply. So now you don't really see anything happening, but we can change the speed to like 100. So now you can see some motion here. You can also increase the speed to like 1000. And if I give a value of -1, we get this effect. We can also have another interesting effect by just adding it with the X, Y, and Z and connecting it here and clicking apply. So it will move everywhere like this. So it will also give a really cool effect. So if I just reduce the radius like that. One more thing we can do is that we can change this multiply to 0.5 and click apply, or like 0.8. And now if I increase this value, it kind of fades out like that. We can also convert this texture to a parameter, and here we can change this to something else. And we can also change the tiling. Now we can have really interesting effects like this. Now for the rest of the post-process material, we will do that later with the blueprints. Now we will create the Niagara systems. So for that, first we will create the material. So I will right click, then material, M underscore beam, and open this up. Now we need to create a beam effect like this one you can see here. So for that, I will just set the blend mode to translucent and the shading model to unlit, and I will also enable two-sided so it will be visible from both the sides. And now we can get a radial gradient here, and now get a particle color. We can multiply this with the radial gradient and also the alpha from the particle color. So we can get the color and alpha from the Niagara system. Now connect this to the MC color and connect this to the opacity. So now we get a dot like this visible from both the sides. Now here we can bring in our purling noise again. So just get the purling noise and bring it here. And now we can subtract the purling noise from the gradient. Now connect it here. So now it should give a look like this. Now we can get a panner to move this around. So here give a value of 0.2 for Y. So it will move upwards and take real time here. So you can see the movement. Now get a constant and set this to 0.7 and get a density value and set this to 1.3. So we get a look like this. Now we can create the Niagara system for this. So click apply. Now in the content browser, we can just right click and get a Niagara system and click next, and then get single looping particle and click add and finish. Now we will call this ns underscore highlight. Now open this one up, and here for the material in the sprite render, we can give this material. Now we have this look. Now here go to the initialize and set the size mode to non-uniform, and now give a value of 70 and 400. So now you can see that it is really stretched. Here we can go to the color mode and give a color to like this. So here you can see that it's tapering off like this. So in order to get this effect, we can go back to our radial gradient and press and hold 2 and click and connect this to the center position. And here with this 2 vector, we can move the center to 0.5 and 0.9 like that. So it will look like this. And now click apply. So now our highlight material looks like this. And we can change the color like that. So now we get a look like this. And now if I just bring it into the world, so here it is not moving with the emitter. So in order to fix that, we can go here and go to properties and click local space. Now we can move this around freely, but here you can see that if I just change the camera like this, it will look like this. This is not what we want. We need it to only rotate around the Z axis. So in order to do that, we can go to the sprite render and set the alignment to custom alignment. And now here we can go to the parameters and go to particle attributes and type in alignment and get sprite alignment and bring that in. And here we can type in system Z axis. So it will just rotate around the Z axis. So now it will just rotate around the Z axis. And from here, it won't really face the camera. But if I rotate around the particle, it will just rotate around the Z axis like this. So this is what we want. Now we can also do few more adjustment to this. So here we can go to the initialize particle and set the lifetime to 1 second. And we can go to emitter stage and change this to self. And for the loop behavior, we can set this to infinite. And here we can untick this and get rate. So spawn rate. And now set this to 2. And we need to blend this in and out. So we can go here to particle update and type in scale color and untick the scale RGB. Now for the scale alpha, we can just click here and type in curve and float from curve and click this curve. So it will just go up to 1 and to 0. So alpha will go from invisible to invisible again. So it will just fade in and fade out like that. So this is what we want. Now we will create the rotating ring effect. Now we will add this circle effect. So for that, right click, material, M_circle, then open it up. Then change the shading model to unlit and the blend mode to translucent. Now here we need to bring in the smoke texture. So here in the starter content, just get the smoke texture and bring that in. Now get a UV coordinate by pressing and holding U and clicking. And now we can just add -0.5 here and multiply this by 2. So now if I just connect it here, I will get something that looks like this. But here, if I get vector to radial value and connect this here and connect this to the UV, I get this rotating circle effect, but there is an artifact. This is because of the way Unreal Engine calculate MIP maps. So if I just select this and change this to absolute, it will go away. Another way is to just expand this. So if I just set this to none, it will show again. But if I go here and select derived, I get this dx and dy. So if I type in ddy and ddx, I can create a MIP map from this one like this, and it should go away also. Now we have this ring. Now we need to rotate this. So now get a multiply and connect this here. Now press and hold 2 and click. So we get this 2 vector and we can give 1 for x and 2 for y and get a panel. And here we can give 3 and 0.3 and -1 and connect this to the UV. So we get this rotating effect like this one. Now we can get a multiply and connect this here, and now get a radial gradient and connect this to the opacity. So now it looks like this. Now here we can get a particle color node and multiply this with this color here. And for the alpha, we can multiply this with this one. We can also add a depth fade here like this. And now click apply. Now we can go back to our Niagara system and duplicate this one. And for the sprite, we can add the one we created like this. And now it is stretched. We can fix that by going into the initialize particle and setting this to uniform. And now we can set a value here like this. And now you can see that it is appearing on top like this. One thing we can do is that we can move this beam up by going into the position mode, then clicking position offset, then giving a value of 300 or 200 like this. So it looks like this. So this is mostly what we want. We can also reduce the color a bit by just connecting it here and giving a value of 0.5. So it is faded a bit like this. This is what we want. Now we will create a blueprint to hold this effect. So right click, then blueprint class, then actor, then here call this BP underscore object, then open it up. Then here we can just add a sphere and we can add a sphere collision and increase the radius a bit. Now we can add our Niagara system here. So just drag that in like this over here. Now we can reduce the size of the sphere by 0.5. So now it looks like this. And here we can also type in custom and set this to custom depth pass of 1. And here we can tick this and set this to 1. So it will highlight. So now I will just drag this in. So now we have this effect. So I will just delete the old one. And here, if I open the scan and increase alpha, you can see that it is highlighted. And here I will just set the speed to like -100. So that's enough, I think. Now we need to create the flying vortex particle. So for that, right click, then Niagara system and click next and select this omnidirectional and click add, then finish and NS vortex, then open it up. Then here we need to disable the gravity. And now we can add a vortex and give it a value of 1200. Now set the alignment mode to velocity so we can stretch this. And now go to particle update and click add and type in scale size by speed. So scale sprite size by speed. And now here give a value of 0.3 and 0.3. And this can be 10 and this 20. So we get a vortex like this. So now we can create a new material for this. So right click and click material and M dot, then open it up. Then change the blend mode to masked and the shading model to unlit. Then get a radial gradient and get a particle color node and get a multiply. And now get a scalar parameter and call this boost and give it a value of 1. So we can control the intensity of the colors. And now we don't really have to connect the alpha to anything because this is a masked material. So just connect the radial gradient to the opacity mask. So we get this disk shape. Now click apply. Now we can go back here and add that in. Here we can go to scale sprite size and click this one, ramp up. So it will start small, then go up, then go down again. So that's what we want. Now we can give it a color for now. And now we can create an instance of this. And here we can just duplicate this one and add that instance. And for this one, I can set this to like 0. I am doing it like this because later we are going to use a curve to control the colors and not the colors here. So in order to make that black, we need to just multiply that with 0. So now this particle will be black. And here we can change the initial size to 6 and 18. So maybe 6 and 12. So it's a bit bigger. So this is what we want. We can also reduce the amount to 50. So it looks like this. So that's all what we want here. Now we will create the blueprint to control the effect. So for that, open up your third person character blueprint. Now here right click and get R keyboard event. So this one. Now we can fade in and fade out the post-process material. When we press R, the post-process material is added to the post-process volume. But later, we will add that to the camera. So here if I just search material, there is this slot for adding post-process material. We will add it here later, but right now we can do some testing by using this. So to do that, right click, then go to material, then get material parameter collection. I will call this PC scan data. I think scan data is a better name. Now we need to add two scalar parameters. One is a alpha and other one is fade out. Then we need to add a vector parameter, and this is to bring in the location of our player. So we can call this location. And now we can go back to the can effect. And here for the alpha, we can type in collection parameter and change this to alpha and connect it here and copy that. We can also replace this alpha with this one. Also this one. And here for the camera position, we can type in collection parameter and we can bring in our fade out and connect this to B and just delete the camera position. Now click apply. Now we can go back to our third person character blueprint and here we can get a timeline and we can call this animate alpha and now connect this press to play from start. Then open this up and change the length to 1 and add a float track and we can call this alpha. Now add a point here and add a point here and change this value to like 1 at time 1 and then we can add an auto curve like this. So it will be a bit smoother. Now we can go back to the event graph and here we can type in set vector parameter value. So this is the location. So if I get data scan, so the one we created, and connect this here and connect this to the play from start. This parameter name is the location we created and the parameter value here we need to provide the location of our mesh. So world location, or you can even provide the location of your capsule component. I think that's better. So I will just get that. So we will draw the circle from the location of the player. So if you have a first person game, you can just use the camera position here like before. And now here in the update, drag and type in set scalar parameter value and then select the alpha for parameter name and now connect this to the parameter value. And now if I press play and press the R key, I can see this scan effect going on like this. And here, if I go to the scan and change the hardness to 0.6, and now if I press R, I get this look. So here I can add like 0.5. So it will be a little bit smaller because we inverted it. Now you can also change the texture here. So if I just set this to water texture like this one, and if I press play, we get this effect. So to get different effects, you can try different textures and also different values here. Now here, if I press R, I get this effect, but I want this to fade out. So in order to do that, we can go back to our material. And here, I can get a lerp and connect this to B. And now I can connect this to A and connect this to the MC color. And for the B, I can get this post-process input 0, copy that and paste it here. so that when this value is 1, we can go back to our normal color. So for that, we can just duplicate this and change this to fade out and connect this to the alpha and click apply. And here we can go back to the third person character. And if I press play and press R, it will show like this because this value is 0 right now. But if this value is 1, then it won't show anything even if I press R. So when we press R, we have to make sure that that value is 0. So we can drag this and type in set scalar parameter, and now change the parameter name to fade out, and for the parameter value it should be 0. And when this timeline is finished, we can call a new custom event. So for that, right click and type in custom event, and we can call this fade out. And here after finished, we will call this. And now here we can add a delay. So we can set this delay to whatever number we want. After that, it will fade out the scan effect. So I will just set this to 2 for now. So it is just for testing. Now we can just duplicate this timeline, and I will call this fade out timeline. Then connect this to fade from start. And here we can just duplicate this fade out parameter and paste it here and connect this to the parameter value. Now if I press play and press R, we have the effect. So I made a mistake here. I am supposed to call this event, not this one. So delete and type in fade out YT, this one. So now if I press play and press R, after 2 seconds, it will fade back out like this. Now let's remove this post-process material from here and add it to the camera. So here. So for that, we can create a new function and we can call this post-process setup. Then here we can drag in our follow camera and type in set post-process, and from this drag and type in make post-process setting and add post-process material here as pin, and drag this and type in make blendables and also make an array here. And here we need to make weighted blendable. So now we can add it here and we can add it to the post-process setup like this, drag it in, and now we can call this pp material. Now since we removed the post-process material from here, if I press play and press R, nothing will happen. But if I just go to the event graph again, and here when I press R, I can call this, and here for this material, I can get this one and add that here, connect this here. So here we need to set this weight to 1, not -1. And now if I press play and press R, we can see the effect and it is fading out. Now, even if it is fading out, it is still there rendering in the background. So we need to remove the material. So in order to do that, we can go to event graph, and here I will just disconnect this for now and just drag this in. And here I will set this to empty, and if I press play and press R, you can see that it is removing the material instantly. So we can disconnect this, and here when this timeline is finished, we can just set this to nothing. So now if I press play and press R, after 2 seconds, it will just go back to normal like this. So this is what we want. Now we can add our vortex material here. So drag here and type in system at location. So spawn system at location, and this location can be this location. And for the asset, this is a vortex Niagara system we created. So just add that. And if I press play and press R, now you can see the effect like this. I think it's a bit slow. So I will just open this up. And for the vortex force, I will give a value of 5000 and 5000. Now if I press play and press R, it's really fast. We will fix the colors later. So here you can see that the particles are always activated. We need to fix that. So in order to do that, we need to activate and deactivate this Niagara system when we press the R key. So in order to do that, we need to communicate with this blueprint actor. So for that, we need to use a blueprint interface. So for that, right click, then go to blueprint, then blueprint interface, and I will call this IF scan call, then open it up. And here we can rename this function to toggle activate. Then we can add an input. We can call this activate and we can add a cost. So that's all we need to do here. Now we need to implement this interface to our actor. So we can go to the blueprint object we created and we can go to class settings, and here you can see interface and implemented interfaces. So now click add and type in if scan call, and now if I go to the event graph and if I just open the interface, if I double click it, I can create an event from it. And if I select this Niagara system, and here if I just untick auto activate, it won't be visible. And now I can just drag this in and get a branch. And if this activate is true, we can type in activate. And if it isn't true, we can drag and type in deactivate. So we can activate and deactivate it with this interface call. Now, in order to find this in the world, there are many ways. So one way is to get all actors of class. Another way is to get all actors with interface. And there is also get all actors with tag. So these are all ways to get a particular actor or actors from the world and do something with them. So because we have implemented the interface, we can use this by using if scan call here, but this will call everything in the level. So in this scan effect, we want something inside the sphere radius and we need to ignore everything else. So if you want to get everything in the level, you can just get all actors with interface. But if you only want to get something inside a radius, one way to do that is by getting multi-sphere trace by object. And here we can get object type by dragging and type in make array. And here we need world dynamic and pawn. World dynamic is any actor like this one, blueprint, and pawn is your character like this. So we need both, and make sure that ignore self is ticked. And here I will just move this out of the way. And now when R is pressed, we will get a sequence node, and we can call this multi-sphere trace also. Now for the start, we can get this capsule location. So duplicate that. And for the end, we will use the same location. And for the radius, this is whatever radius you want. So I will just set a radius of 3000. So this is whatever you have. And here I will promote this hit result to a variable. And now we have this array. Now we want to call this event for all the actors in the array. So here I can drag in the array and type in for loop. So this will loop through all the actors inside the hit result. And now I can just break the hit result here. And here we have this hit actor. And if I drag it and type in call toggle activate from the if scan call interface, and now I can just tick activate. And now if I press R, so here you can see that it is not activated. And if I press R, you can see that now it is activated, but it is not getting deactivated. So in order to do that, we can go here and drag this in, and also get a for loop here. And here just break this, and with the hit actor type in call toggle activate, and I will just leave this unticked. So if I press play and press R, you can see that it is activated. Now after that it is deactivated. So this is what we want. So here we can also clear this hit results before we scan again. So just clear it. And one more thing I want to show you is that if I go to the object blueprint, and here if I just add a print string of hello, and if I press play and press R, you can see that the hello is called 2 times. I think that's because there is 2 things to collide with. So if I just set this to no collision, and if I press play and press R, it will only call this 1 time. So I don't really know any other fix to it. One solution may be to use a trace channel. So there is pair trace by channel and profile. You can create a new channel and only set that to hit this object, but then you have to do that in the project settings, etc. Another way is to just to go here and type in do once. So it will only call this once, and if I just connect this to the reset, and here if I set this to block all dynamic again, and if I press play and press R, it only called it 1 time. So like you can see only one hello there. So that's a fix, but this can break if we spam the R key and scan. So we need to prevent that by getting a boolean. So, and we can call this is scanning, and now we can get a branch, and if this is false, so this is scanning is false, only then we can call this scanning. And when it is called, we can set this to true, and when this scanning is over, here we can reset this to false. So now if I press play and press R, here I cannot spam the scan. So after it is over, I can call this again. Now we can duplicate it by 3 times. So we can have enemy, friendly, and neutral. So in order to do that, we also need to create an enum. So right click, then blueprint, then enumeration. I will call this enum underscore type, then open it up, then add 3. So the first one is enemy, and the second one is neutral, and the third one is friend. And now we can go to our actor, and here we can create a new function, and we can type in set type, and now here we can add the enumeration. So here type in type, and for the type we can type in enum type. So we will select this one. So click this eye icon. So if I just click this and press combine, if I select this, and I can select which one is this from the editor itself. So that's really useful. And now go back, and here we can drag this in, and here now we can drag the sphere in and type in set custom depth. So set render custom depth, and connect this here and tick this. Now drag it again and type in set stencil value, and here we can just drag this and type in select, and we can connect this here. So if it is enemy, we will give a value of 1, and if it is neutral, we will give a value of 2, and if it is friendly, we will give a value of 3. So click compile, and now we can go to our scan material, and here, so the 1 value is for the enemy and the 2 value is for the friend, but we can just switch that. So we can switch this to 3 and this to 2, and it should work. And here if I just select this and set this to neutral and this one to friend, so now we can go back to the actor, and here we need to call this event. So just drag this and connect this here. So we can also drag this out like this and click compile, and we can drag in the sphere from here. So it's much better if you want to copy the function. So here we need to add the sphere mesh, not the collision. So this one is a collision. We need to add the mesh. Now if I just press play and press R, you can see that they all have different colors. Now we need to change the color of the particle system. So for that, we can go to the particle system, and here in the user parameter, we can add a color and select linear color, and we can call this just type color, and also copy that and just drag that in here and also here. Now go back to the actor, and here we can drag this in, and now type in set Niagara variable linear color and paste the name, and just drag and type in select and connect this here again. Now we can promote this to a local variable. So enemy, and also this one neutral, and this one friendly. Now we can set each of the colors. So we can give a red value to the enemy, and for the neutral we can give an yellow value, and for the front we can give a green value. Now if I press play and press R, so here for the enemy we also need to set the alpha value to 1, and now if I press play and press R, now you can see that it is highlighting properly. So now we can just delete the print string. Now we can add the curve assets to control the color of the scan and also the particle system. So for that we can right click, then we can go to miscellaneous, then go to curve atlas, and I will call this CAT can atlas, then open it up. We can untick the square resolution and set this to 4 or something like that. We really only need a thin strip, and we can set this to 256 or maybe 128. So that's all we need. Now we can create a curve. So right click again and miscellaneous, and we can go to curves and linear color and select that, and we can call this CB can. Then here we can add a point and add a blue color like this, and here I can click here and add a darker color like this, and now click save and go back to the scan material, and here instead of the noise color I can move it here, and I can type in curve atlas row parameter, and I will call this curve, and now here for the atlas we will choose the one we created, and now for the curve we need to add that here in the atlas. So we can go to gradient curves, and here we can click add, and for the index we can add this curve in. So now we can choose that, and we can just connect this here, and we can just ignore the color and connect, and just connect it like this and click apply. And now if I press play and press R, it is not really visible. So we can increase the color to like 1000. Now if I press R, it is visible, but only a few spots. So I can move this here. So now it is more visible. So in order to make this better, we can change the material here to Perlin noise. And now if I press play and press R, so now it's really bright. So I can set this value to like 200, and I can bring it here like this. And now if I press play and now if I press R, it looks like this. So maybe bring this here, and for this multiply I will change this to 0.2 2 here and click apply. Now if I press R, I get this look. Now we need to change the color of the vortex. So go to the dot and here we can type in curve, add less, and we can connect this here and connect this here and select the curve we created and this color. And now click apply. And now if I press R, the colors are like this. So I will just open the vortex, and here for this color mode I will just unset this. We don't really want any colors. And here for the scale RGB we don't really want that either. And other than that, now if I press play, so it's still white. That is because this material is masked, so our post process is affecting it also. So if I change this to translucent, and now we can just get a multiply and connect this alpha and connect this here and connect this to the opacity. Now if I press R, so we will have our color. Now here I can change this hue like this to yellow, and now if I press play, I get this look. So this is what we want. So here the last thing I want to show you is how to add multiple colors to your curve like you saw at the start of the video. So in order to do that, we can go back to the curve and click here and also click here and set this value to like 0 and 0, and in the middle you can click again and add a color like this. And now if I press play, and now if I press R, you can see that I have a different color inside the texture like this. So here I can change this color to something else like this one, and I can also change the width like this so it is more visible. Now if I press play and press R, I get an effect like this. Can also increase this value to like 60, and also change these. And if these colors doesn't really work well, you can also fix them here by moving the individual channel points, like for green, blue, red, etc. You can also try making them smooth like this. Now if I press R, I get a look like this. So you can play around with this curve value to get really cool looking effects by controlling the colors on different areas here. So I think that's it for the tutorial, guys. Thank you very much for watching. This was a really long tutorial, and if you want to support my channel and download the project files, you can support me on my Patreon.